Dear students, welcome to our YouTube channel ChemOrigin. This is Dr.Satish Kumar. Students, in this video module, we discuss about the colligative property osmotic pressure. Students, in the previous video modules, we already discussed the colligative properties: lowering of vapor pressure, elevation in the boiling point, depression in the freezing point, along with some numerical problems. So students, in the present video module, I would like to discuss about the colligative property osmotic pressure. Now students, we can start our class. Students, next colligative property is osmotic pressure. Osmotic pressure. Now we can see detailedly about the colligative property osmotic pressure. Osmotic pressure. Osmotic pressure. Students, before going to see about the osmotic pressure, we should discuss about the osmosis. So what is osmosis? We can see first osmosis. What is the osmosis? Later we can discuss detailedly about the osmotic pressure. Osmosis. So students, if you take a container which should be divided into two compartments. So students, let us take a container. Let us take a container. It should be divided into two compartments. You can take a container. It is divided into two compartments. So with a semi-permeable membrane. Students, you can take a container. You can take a container. It is divided with a semi-permeable membrane. It is divided with a semi-permeable membrane. Semi-permeable membrane. Students, let us assume this is container number 1 or compartment number 1. So students, this is compartment number 1 and this is compartment 2. So students, we can take a container and divide the container into two compartments with the help of a semi-permeable membrane. Semi-permeable membrane. Students, in this is the semi-permeable membrane. So students, in a container you can take two solutions or a solvent and a solution, or you can take a dilute and concentrated solution which are separated by a semi-permeable membrane. Semi-permeable membrane. Semi-permeable membrane. Then what happen? Students, spontaneously the solvent molecules will flow from solvent to a solution or a dilute solution to a concentrated solution. Suppose students, you can take pure solvent. Suppose you can take pure solvent. You can take pure solvent in compartment 1. Students, suppose you can take pure solvent in compartment 1 and you can take a solution in compartment 2. Then what happen? Students, spontaneously the solvent molecules flow from solvent to a solution through a semi-permeable membrane. This is known as a osmosis. So students, we can define osmosis as the spontaneous flow of solvent molecules. The spontaneous flow of solvent molecules. The spontaneous flow of solvent molecules. The spontaneous flow of solvent molecules through a semi-permeable membrane. Through a semi-permeable membrane. Through a semi-permeable membrane. Through a semi-permeable membrane from pure solvent to dilute solution. From pure solvent to solution. From pure solvent to solution, or from a dilute to a concentrated solution. From dilute to a concentrated solution is defined as the osmosis. The spontaneous flow of solvent molecules through a semi-permeable membrane from a pure solvent to the solution or from a dilute solution to the concentrated solution through semi-permeable membrane is known as a osmosis. So students, now we can discuss about the osmotic pressure. Whenever students, whenever the solvent molecules flow from pure solvent to the solution, there is a hydrostatic pressure. There was a hydrostatic pressure was generated. A hydrostatic pressure was generated in the solution compartment or concentrated solution, which just which just stop the osmosis. So a pressure is built up on the solution compartment or concentrated solution compartment, which just stop the osmosis. Therefore students, we can define the osmotic pressure. The osmotic pressure is defined as a osmotic pressure it is defined as a it is defined as a the hydrostatic pressure which built up on the solution, which is defined as a it is defined as a the hydrostatic pressure. The hydrostatic pressure built up on the solution. The hydrostatic pressure built up on the solution, which just stop the osmosis, which just stop the osmosis which just stop the osmosis is known as a osmotic pressure. Therefore students, we can conclude that osmotic pressure is equals to the hydrostatic pressure. It is defined as the hydrostatic pressure is built up on the solution which just stop the osmosis is known as a osmotic pressure. Students, this osmotic pressure is generally denoted with a symbol pi. So students, the scientist whose name is Van 't Hoff, the scientist Van 't Hoff is identified that there is an analogy between the gases and solutions. Based on that, Van 't Hoff introduced a Van 't Hoff theory of dilute solutions. Van 't Hoff theory of dilute solutions. So students, Van 't Hoff, the scientist name, he introduced a theory is known as a Van 't Hoff theory of dilute solutions. So students, the scientist Van 't Hoff identified or realized that there was an analogy. Van 't Hoff realized Van 't Hoff realized that the scientist Van 't Hoff realized that there was an analogy. There was an analogy exists. There was an analogy exist between the there was an analogy exist between the gases and solutions provided provided the osmotic pressure provided osmotic pressure to solutions 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 is used in place of is used in place of is used in place of ordinary gas pressure is used in place of ordinary gas pressure is used in place of ordinary gas pressure. So students, Van 't Hoff realized that there was an analogy. There was an analogy exist between the gases and solutions. So there is some similarities between the both gases and solutions, and he identified the pressure which is exist in the solution as a osmotic pressure in place of the ordinary gas pressure. So students, based on this, Van 't Hoff introduced some laws. The first law is Boyle-Van 't Hoff law. The first law is Boyle's Van 't Hoff law. Now we can see the first law is Boyle-Van 't Hoff law. Boyle-Van 't Hoff law. It is known as a Boyle-Van 't Hoff law. So students, according to Boyle's Van 't Hoff law, the pressure, the osmotic pressure of a solution, the osmotic pressure or the osmotic pressure P or pi, the osmotic pressure of a solution, the osmotic pressure of a solution is directly proportional to the is directly proportional to the is directly proportional to the constant directly proportional to the concentration of the solution, or directly proportional to its concentration when the temperature is kept constant, when the temperature is constant, when the temperature when the temperature is kept constant, when the temperature is kept constant, when the temperature is kept constant. So students, according to Boyle-Van 't Hoff law, the osmotic pressure of a solution is directly proportional to its concentration when the temperature is kept constant, when the temperature is kept as a constant. So students, we know that, so we can write like this, thus we can write like this: P or pi is proportional to C. Therefore students, we can write P is proportional to concentration C. P is proportional to concentration C. That implies P is proportional to C. So students, suppose if you use n 1 gram moles, students, if you take if you take 1 gram 1 gram mole of solute, 1 gram mole is dissolved in 1 gram mole is dissolved in v liters of solution, v liters v liters of solution, then the concentration, if you take 1 gram mole is dissolved in v liters of solution, if you take 1 gram mole of solution, 1 gram mole of solute is dissolved in v liters of solution, then concentration C becomes, then concentration C is equals to 1 by V. C is equals to 1 by V. Therefore students, from the above equation we can write like this. So students, let us assume this is as a equation number 1. So students, you can assume this is as a equation 1, that is P is proportional to C. So students, if you use 1 gram mole is dissolved in V liters of solution, then concentration is equals to 1 by V. Therefore students, we can write this equation like this. So students, we can write the equation in this way, that is P is proportional to C can be written as a P is proportional to V, that is P is proportional to 1 by V. P is proportional to 1 by V. And students, that implies we can write P into V. We can write P into V is constant. That implies P into V is equals to constant. P into V is equals to constant. Similarly students, for solutions, the osmotic pressure is denoted with pi. Therefore we can write as a pi V is equals to constant. Therefore we can write pi V is equals to constant. This is Van 't Boyle's law. Next students, we can see Van 't Next we can see Van 't law. Law. Students, from gases we know that law, at a constant volume, pressure of a gas is directly proportional to absolute temperature. Students, we know that for gases at a constant volume, pressure of a gas is directly proportional to absolute temperature. Now students, we can discuss about the Van 't law. We can discuss about, this is second law. Students. Van 't law. Van 't law. So students, according to Van 't law, the osmotic pressure of a dilute solution, the osmotic pressure of a dilute solution, the osmotic pressure of a dilute solution, The osmotic pressure of a dilute solution is directly proportional to the absolute temperature at constant concentration at constant at constant concentration at constant concentration. Therefore, students, we can write like this. That implies P. That implies we can write P is proportional to absolute temperature. P is proportional to absolute temperature. Therefore, P is proportional to absolute temperature at constant volume. Therefore, students, we can write P by T is equals to constant. Therefore, students, we can write P by T is equals to constant, or you can write like this, students, or you can write pi by T, or we can write pi by T is constant. Therefore, students, we can write like this: pi by T is constant, since pi is the osmotic pressure of the solution. Therefore, we can write pi by T is equals to constant. Students, let us assume this is as a equation number 2. Students, we can assume this is as a equation number 2. So students, from equation 1 and 2. So students, from equations 1 and 2, we can write like this. Therefore students, from equations 1 and 2, from equations 1 and 2, from equations 1 and 2, the first equation is P is proportional to C, and from the second equation P is proportional to T. We can write like this, students: P is proportional to C into T. P is proportional to C into T. And also students, we can write like this. You can remove the proportionality with a proportionality constant. Let it be S. Then P is equals to SCT. Then P is equals to SCT. Students, we know that from first law, C is equals to 1 by V. For 1 gram mole is dissolved in V liters of solution. The solution containing 1 gram mole in V liters of solution, C is equals to 1 by V. Therefore, students, we can write P is equals to S into 1 by V into T. S into 1 by V into T. That implies, students, we can write PV is equals to S into T. PV is equals to S into T, or we can write pi V is equals to S into T. We can write PV is equals to S into T, or we can write pi V. Pi V is equals to S into T, where pi is the osmotic pressure. So students, in the above equation, the proportionality constant is known as a molar solution constant. Therefore, students, where in the above equation, where capital S, is known as a, where capital S is a molar solution constant, where capital S is a molar solution constant, and the value of S is equals to 0.0821 liters atmosphere, 0.0821 liters atmosphere per mole per Kelvin is the molar solution constant. S equals to 0.0821 liters atmosphere per mole per Kelvin. So students, the above equation is for the solution, the solution containing 1 gram mole, the solution containing 1 gram mole in V liters of solution, 1 gram mole in V liters of solution, 1 gram mole in V liters of solution. So the solution containing 1 gram mole in V liters of solution, we get PV is equals to ST, or pi V is equals to NST. Suppose students, if the solution if the solution is having, if the solution, if the solution containing n gram mole in V liters of solution, then the equation becomes PV is equals to NST, or we can write, or we can write pi V is equals to NST, pi V is equals to NST, pi V is equals to NST. So PV equals to NST or pi V equals to NST, where N is the number of moles of solute dissolved in the solvent. Pi V is equals to NST. Students, the third law for Van 't Hoff theory of dilute solutions. The third law is, students, equimolecular solutions, equimolecular solutions of different solutes, equimolecular solutions, equimolecular solutions, equimolecular solutions of different solutes, of different solutes exert, of different solutes exert equal osmotic pressure, exert equal osmotic pressure under identical conditions of temperature, exert equal osmotic pressure under identical condition of, under identical conditions of temperature, under identical conditions of, identical conditions, under identical conditions of temperature, under identical conditions of temperature. So students, such solutions which have, such solutions which have same osmotic pressure, such solutions which have same osmotic pressure are known as a, are known as a isotonic solutions, are known as a isotonic, are known as a isotonic solutions, isotonic solutions. So students, two solutions which have the same osmotic pressure at a constant temperature is known as a isotonic solutions. Equimolecular solutions of different solutes exert a equal osmotic pressure, exert a equal osmotic pressure, exert a equal osmotic pressure under identical condition of temperature. Such solutions which have the same osmotic pressure are known as a isotonic solutions. So students, for this the Avogadro hypothesis is, for this the Avogadro hypothesis, Avogadro hypothesis is, Avogadro hypothesis is equal volumes, equal volumes of solutions, equal volumes of solutions of different solutes, equal volumes of solutions, equal volumes of solutions of different solutes, of different solutes, of different solutes at the same, at the same temperature, at the same temperature and osmotic pressure, at the same temperature and osmotic pressure contain, contain equal number of molecules, contains equal number of molecules, equal number of molecules. So students, equal volume solutions of different solutes at constant temperature and osmotic pressure or at similar temperature and osmotic pressure contains equal number of molecules, contains equal number of molecules. For example students, if you take for a solution 1, for solution 1, for solution 1, for solution 1 the osmotic pressure is PV is equals to, for solution 1 PV is equals to N1ST, for solution 1 PV is equals to N1ST, and similarly for solution 2, for solution 2 PV, for solution 2 PV is equals to, PV is equals to N2ST. When therefore from the Avogadro hypothesis, therefore we can write N1 must be equals to N2, thus N1 must be equal to N2, N1 must be equal to N2 if if the pressure, volume and temperature are same. If the pressure, volume and temperature are same, the number of moles of solutions which are having different solute must be equal. N1 must be equal to N2 if the pressure, volume and temperature are same. Students, we know that the main application of colligative properties is to determine the molecular masses of the solutes. So next we can see determination of molecular masses, determination of molecular masses. So students, in the determination of molecular masses of solute with the help of colligative properties, so students, we can see how we can determine the molecular mass of a solute. Students, we know that for dilute solutions, we know that PV is equals to NST. Students, for dilute solutions, we know that PV is equals to NST, where N is the number of moles of solute. N is equals to number of moles of solute. Students, let us assume a solute whose mass is, solute of mass WA having molecular mass MA. So students, let us assume a solute of mass WA and molecular mass as MA. Let us assume, students, a solute of mass WA and molecular mass MA. Then the equation becomes, then the above equation can be written as, like this. That implies PV is equals to, we can write PV is equals to WA by MA as into ST. So we can write WA by MA into ST. So students, PV is equals to WA by MA into ST, where WA is the mass of the solute and MA is the molecular mass of the solute. Therefore, students, we can assume WA grams of solute of molecular mass MA is dissolved in V liters of solution. Therefore, students, the molecular mass of the solute MA is equals to WA into ST by PV. Therefore, we write WA into ST by PV. So by using this relation, students, we can determine the molecular mass of a solute, that is MA is equals to WA into ST by PV. Suppose students, let us take two solutions. So students, let us assume two solutions. Having N1 and N2 moles. Having, let us assume two solutions having N1 and N2 moles in V1 and V2 liters of solution respectively. V1 and V2 liters of solution respectively. And students, you can assume, let the osmotic pressure is P1 and P2. Let us assume the osmotic pressures for the two solutions as a P1 and P2. So students, you can assume two solutions you can assume two solutions of osmotic pressure P1 and P2, and the volume for the two solutions is V1 and V2, and the number of moles of solute in one solution is N1 and another solution is N2. Therefore we can write like this, students, for solution 1. Therefore from the equation for solution 1, for solution 1 we can write, for solution 1 we can write P1 V1, P1 V1 is equals to N1 ST, P1 V1 is equals to N1 ST. So students, P1 V1 is equals to N1 ST. So P1 is the osmotic pressure, N1 is the number of moles, and V1 is the volume. Similarly students, for solution 2, for solution 2 we can write, for solution 2 we can write P2 V2 is equals to, P2 V2 is equals to N2 ST, P2 V2 is equals to N2 ST. So students, just now we discussed the isotonic solutions. So the two solutions which have different solutes having the same osmotic pressure is known as a isotonic solutions. Therefore, if these two solutions are, if these two solutions are isotonic, if these two solutions are, if these two solutions are isotonic, if these two solutions are isotonic, then we can write P1 is equals to, students, then we can write P1 is equals to P2. Then we can, if that these two solutions are isotonic, we can write P1 is equals to P2, P1 is equals to P2. So students, for solution 1, for solution 1 P1 V1 is equals to NST, this equation can be written as a P1 is equals to, this equation we can written like this, P1 is equals to N1 ST by V1, or we can write like this, P1 is equals to, P1 is equals to N1 by VST. So students, we can write P1 is equals to N1 by V1 ST. Students, from the equation for solution 1 we can write P1 is 1, P1 is equals to N1 by, P1 is equals to N1 by V1 ST, N1 by V1 ST. We can write like this, P1 is, P1 is equals to N1 by V1 ST. Similarly students, for solution 2, for solution 2 we can write like this, P2 is equals to, P2 is equals to N2 by V2 into ST. So similarly students, for second solution we can write P2 is equals to, P2 is equals to N2 by V2 ST, P2 is equals to N2 by V2 ST, P2 is equals to N2 by V2 ST. Similarly, P1 is equals to N1 by V1 ST. Therefore, students, if these two solutions are isotonic, then P1 is equals to P2. Hence, we can write like this, students, N1 by V1 ST is equals to N2 by V2 ST. So, students, we can write like this. We can write like this, from these two relations. We can write N1 N1 by V1 ST is equals to, N1 by V1 ST is equals to N2 by, N2 by V2 ST. N1 by V1 ST is equals to N2 by V2 ST. That implies, students, S is a molar solution constant. For isotonic solutions, we know that, students, temperature remains the same. Therefore, students, N1 by V1, we can write the above relation as a N1 by V1 is equals to N2 by V2. So students, this is the condition for isotonic solutions. So students, this is the condition. This is the condition for isotonic solutions. This is the condition for isotonic solutions. Okay students, this is the condition for isotonic solutions. Therefore students, for isotonic solutions, N1 by V1 is equals to N2 by V2. Okay students, I hope you enjoyed this session. Students, in this video module, we discuss about the colligative property osmotic pressure, and along with that, we also discuss the Van 't Hoff theory of dilute solutions, that is Boyle-Van 't Hoff law, Gay-Lussac-Van 't Hoff law, and third law. So that is Avogadro hypothesis, and based on that we can develop an equation for calculation of osmotic pressure, that is as a pi v is equal to nst. So students, thank you very much.